Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
Engine malfunction causes more fuel to enter the cylinders. The mixture is over-enriched, resulting in increased fuel consumption. It is also possible that due to a malfunction in one of the life support systems, engine power is reduced. Therefore, to move the car in normal mode, the driver needs to pedal more actively, and the electronic engine control unit engine control unit is forced to supply a large portion of fuel to the cylinders. Low tire pressure. The vehicle is fitted with non-standard equipment. First of all, we are talking about kangaroo on which some drivers like to install lights of additional lighting. Such tuning elements increase the coefficient of drag. At the same time, the higher the average speed of the car, the greater will be the fuel consumption. The absence of the lower part of the bumper, the so-called lip, negatively affects fuel consumption. It is designed to cut off the airflow from the bottom of the nose part, thereby reducing parasitic whirls under the bottom of the car. At high mileage on the highway, the absence of aerodynamic element will show itself by extra 0.5 liters of burned fuel. Non-standard equipment can also include the fitting of larger wheels. Wide tires increase rolling resistance, while massive rims and high-profile rubber increase the total weight of the wheel. More energy is required to spin the increased weight and maintain speed, which translates into higher fuel consumption. Impact of tire pressure on gasoline consumption. In search of the causes of increased fuel consumption, many drivers only at the last moment remember about tire pressure. But how is this parameter related to high gasoline consumption? It is quite difficult to conduct an objective experiment in real road conditions. After all, fuel consumption is influenced not only by tire pressure, but also by air temperature, roadbed temperature, direction of oncoming wind, and traffic. Available tests show that reducing tire pressure by 0.5 atm increases fuel consumption by about 5%. But that doesn't mean you should overinflate your tires in pursuit of lower consumption. With overinflated tires there is uneven wear, increased stress on the chassis of the car, as well as an increased risk of serious damage to the disc and tire when hitting a bump. Octane rating. Fueling an injector car with low-octane fuel is guaranteed to reveal high consumption. When the engine runs on low-octane gasoline, detonation occurs. To protect the cylinder from the devastating effects of detonation, the ECU rolls back the ignition advance angle, reducing the pressure in the combustion chamber. When the piston reaches TDC, prevents detonation, but at the same time reduces the amount of energy obtained from combustion of the air-fuel mixture. AI-92 gasoline is especially dangerous for turbocharged heat-loaded internal combustion engines. Sensor malfunctions. In the rating of causes of high fuel consumption, the first place is rightfully occupied by a faulty oxygen sensor. The lambda probe signal allows the engine ECU to determine enriched or depleted TPMS. In the case of a malfunction, the sensor can produce a signal of a depleted mixture, so the ECU will increase the portion of fuel injected. With a significant deviation from the stoichiometric composition, the temperature and speed of combustion decreases, so some gasoline simply flies into the exhaust pipe without producing useful work. Based on the signal from the DMRV, the ECU of the injection system calculates the amount of air entering the intake manifold. In case of sensor malfunction or reduced sensitivity due to contamination, the actual amount of air will differ from the sensor readings. Therefore, the mixture may be permanently enriched, which will lead to increased gasoline consumption. Incorrect readings of DAT and DTV can lead to similar consequences. Also, to high fuel consumption will lead to incorrect readings of DTOJ. The engine control unit takes into account information about the degree of engine warm-up to regulate the fuel-to-air ratio. As with the DMR and lambda probe, false DTOJ readings can cause the ECU to over-enrich the mixture. Mechanical problems: air suction in the exhaust manifold. A crack in the exhaust duct up to the oxygen sensor or a leaky joint between the manifold and the cylinder head leads to oxygen intake. Lambda probe registers excess oxidizer and gives a signal of too lean mixture. In conclusion, understanding the causes of increased fuel consumption is crucial for maintaining vehicle efficiency and reducing costs. As we've explored, the two primary reasons for gasoline overconsumption are either a malfunction that raises the cycle rate or an increased load on the engine. By identifying issues such as faulty injectors or excessive weight, drivers can take proactive measures to improve fuel efficiency. Regular maintenance and awareness of vehicle performance can lead to significant savings and a more sustainable driving experience. Thank you for watching, and be sure to stay tuned for more insights on optimizing your vehicle's performance.